Yes, we progress on polynomial equations as we now talk about a very interesting theorem called the remainder theorem. In the I think in the third video where we talked about division, polynomial division, where we talked about long division and synthetic division, um, we I did some things related to remainder theorem right there, but here we're bringing it right home. So let's go for that. Remainder theorem. The remainder theorem connects polynomial division, like I said, with function evaluation. Okay, and this is pretty powerful, and it provides a very nice way to work around a polynomial. So it tells us that to find the remainder when dividing a polynomial by a linear factor x minus c, we just need to evaluate the polynomial at x equals c. Very simple stuff. So what this is telling us is that if you need to divide like what I did yesterday, if you need to divide x raised to power 4 minus 1 by x, is that plus now? I think it's plus. Yeah, I think it's plus. Whatever it is, even. So if you want to divide x raised to power 4 minus 1 by x, if you want to divide x raised to power 4 minus 1 by x minus 7, okay, all you just need to do is to evaluate. All you just need to do is to evaluate the polynomial at x equals c. So in short, just like I did in that, I think it was third video, just like what I did there. So I can just ask a simple question. What is the remainder? What is the remainder? What is the remainder? Okay, when x raised to power 4 minus 1 over when x raised to power 4 minus 1 is divided by x minus 7. Okay, that's the question. So I'll come back to answer that once we are done with other parts. So that's the theorem, right? So the remainder theorem connects polynomial division with function evaluation, and it tells us that to find the remainder when dividing the polynomial by a linear factor, x minus c, don't forget it has to be a linear factor. So you see, x minus 7 is a linear factor. If it is x squared minus 7, then it's no longer linear. Okay, it has to be x minus 7, x plus 7, x just first order, right? So in this case, let's talk about the statement of the remainder theorem, some kind of statement to establish it. So let P of x be a polynomial and let C be any real or complex number, right? When we divide P of x by the linear polynomial x minus C, so we get P of x just like what we did for the, when we talked about division. So the divisor, P of x, is equal to the dividend multiplied by the quotient plus the remainder. I mean, we've done that quite a couple of times. So where okay, well, I mean, if I want to do that in simplified terms, I think I use the case of 9. So you have 9 over 4. 9 over 4 is 2, 1 over 4. So if you multiply through by 4 now, it's like you have 9 to the 4, the divisor multiplied by the quotient plus 1. That's what that is about. So here now, like I've always said, this is the dividend, okay? This is the divisor, okay? And this is the quotient, the result you get when you divide, and then you have the remainder, okay? That's the idea all the way. So for numbers now, you can relate with that easily. So with that, we want to bring that into the case of polynomials. So that's exactly what you have right here. So where Q of x is a polynomial called the quotient, and R is a constant, which is a number called the remainder, with degree R, the degree of the remainder is always less than the degree of the divisor, because I mean, so usually, right, just like if you do it with numbers, the degree of the remainder, the remainder is always smaller than the divisor. So if after dividing you still have something bigger, you still have a remainder that is bigger than the divisor, it means something is wrong with your division. So you want to check to be sure. So the degree of the remainder is always less than the degree of the divisor, and which is equal to usually the degree of the divisor is usually equal to 1, because we're talking about a linear polynomial x minus c as divisor, right? So the degree of r has to be less than the degree of x minus c, which is 1. So means that the degree of r has to be 0. That's the basic thing. So that's why the r is usually a constant. So the remainder theorem then says that remainder when p of x is divided by x minus c is simply p of c, right? So to make that clear enough, so the remainder, all right, so if we say if f of x is equal to x raised by 4 minus 1 is divided by x minus 7, okay, the remainder, the remainder is simply f of 7. That is, if you equate this to, if you say x minus 7 equals 0, if you do that equation and you get, so it means you get x equals 7. Okay, so f raised power 7, that's f of 7, that's 7 raised power 4 minus 1, which is 2401 minus 1, and that is 2400. And that was what I did in the other video. So if you divide x raised power 4 minus 1 by x minus 7, you get 400, 2 times 2400 easily. Okay, so the remainder theorem simply says that the remainder when p of x is divided by x minus c is p of c. If in symbols, if the remainder is r, then the remainder r is p of c. Simply, that's what that is telling us, and that has been established right here. Even when I did the long division, that was exactly what I got. So now proof idea using the polynomial division algorithm. So just something to explain. So from the division algorithm, we can write that p of x is x minus c multiplied by q of x plus r. That's dividend. Dividend equals divisor multiplied by quotient plus remainder. So for some polynomial q of x and some constant r. Now, if you substitute x to be c, so if x, x means that is the value of x, that's the 0 or something. So if x is equal to c, if you substitute x equals c into these identities, you have p of c equals c minus c, q of c plus r. So c minus c is 0. 0 times q of c, you have that plus r. So at the end of the day, you just have r. So it means that if you substitute that constant, whatever you have left is your remainder. Therefore, the remainder, when p of x is divided by x minus c, is exactly p of c. And we have established that amply. So imagine, let p of x be 2x cubed minus 3x squared plus 4x minus 5. Find the remainder when p of x is divided by x minus 2. So normal thing you should do is you set up the long division and start doing all the story. But because of this remainder theorem, life is so easy. So just say x minus 2 is 0. That means that x is equal to 2. Substitute 2 into this expression, and whatever you get is your remainder. Okay? So by the remainder theorem, the remainder is p of 2. So that's p of 2. That's 2 into 2 raised power 3 minus 3 into 2 raised power 2 plus 4 times 2 minus 5. So 2 raised power 3 is 8 times 2, 16. 2 raised power 2 is 4 times 3, 12. 4 times 2 is 8 minus 5. So you have 16 minus 12, 4 plus 8, 12. 12 minus 5 is 7. So the remainder is 7, and we can write that p of x is equal to x minus 2. So in this case now, you don't even need to know the quotient because your focus is on the remainder. So if you're looking for the remainder, you can just go for it. So p of x equals x minus 2 q of x plus 7 without knowing the quotient, but you can know the remainder. And that is for the polynomial q of x, whatever that is. Okay, so then we can have a kind of intuitive or graphical picture of that. So the value p of x, okay, the value p of c rather is the height of the graph of y equals p of x at x equals c. So, I mean, since I've done an example before, I think I want to go to Desmos and demonstrate it so you can understand what that is about. Desmos, so I go open Desmos and I go for graphing. Okay, so here we have, so I want to say I need x raised to power 4, okay, minus 1 divided by x minus 7. So you see what's happening here. So check at x at 7, okay, at 7, at x equals 7, there must be something happening there. Okay, good. Okay, we are still saying this. Except that it is a long way away. It looks like a very hyperbolic thing. So at 7, okay, you can see this line is approaching, is moving towards 7 as we go further and further. So you see we're still going. Well, I mean, it's still a long way away because it's such a hyperbolic thing. So you can see it's moving so fast. So you can see it's approaching, it's moving towards 7. So it's now it's moving close to 6 now. With time, it crosses 6. It will cross 6 and it's moving towards 7. Gosh, this is a lot. Okay, once it goes beyond 6, I'll stop because to get to 7, it's gonna take a long. I'll have to keep doing this. Okay, see, it's getting to 6 now. It's getting to 6, gradually getting to 6. Then it will cross 6 and it will keep going. Okay, now it's crossed 6. Okay, I mean it's crossing 6. It's safer to say it's crossing 6. Okay, it has crossed 6 and it will keep going. But you can see this value is so large now. So that's the deal there. So the number blows up so quite easily. Okay, so the polynomial q of c minus x minus c times q of x always has a root at x equals c. So its graph crosses or touches the graph at x equals c, right? So that's why that thing, if I keep going, it will move towards 7. So if p of c is equal to 0, then the point c comma 0 lies on the graph y equals p of x, and x minus c is an exact factor. So what we are basically saying with that is that if by the time you divide, if your answer here is 0, it simply means that this x minus 7 is a perfect factor of x raised to power 4 minus 1 without remainder. Of course, that's what the next video is about, which is about factor theorem, and that's useful for some other applications. So watch out for that. Okay. So if P of C is equal to 0, if by the time you substitute that value, you get 0, it means that the expression it comes from, is actually a factor. So it means that the point c comma 0 lies on the graph of y equals P of x, and x minus c is an exact factor. So, and when it comes to factorizing, factorizing quadratic expressions is pretty easy, relatively. But if you want to factorize like a cubic, quartic, quintic, or higher functions, you may need to use this remainder thing to see what's the factor of a particular expression or not. So let's talk about quick computation of P of C using synthetic division. Okay, synthetic division is a shortcut method for dividing a polynomial P of x by a linear factor x minus c. Now we already talked about this in the video, I think video 3, talking about polynomial division. So because of the remainder theorem, the last number in the synthetic division process is exactly P of C. So in synthetic division, the last number you have is the remainder, and that's in long division to the last number you have is the remainder. But synthetic division makes things a bit faster, and now I've even found a very cool way to actually do synthetic division without wasting time, right? So that P of C now gives the remainder when dividing P of x by x minus c. So set up for synthetic division by x minus c. So imagine you have the polynomial P of x, which is an x raised to power n plus an minus 1 x raised to power n minus 1 plus all this plus a1x plus a naught. So to perform synthetic division by x minus c, like I said, so write the number c on the left, write the coefficients an minus 1, a1, a naught in a row, bring down the first coefficient, an. I'm going to explain all this, so not a problem. Then multiply the number just written at the bottom by c. Then write the result under the next coefficient, add down to get the new bottom number, repeat the multiply by c, then add process across the row. The final bottom number is the remainder r, which is P of c. Then the other bottom numbers are the coefficients of the quotient polynomial Q of x. So that looks like a lot, but we can demonstrate that using this thing here. So all that we have explained is what we have here now. So using synthetic division to compute P of 2. So imagine you have P of x equals 2x cubed minus 3x squared plus 4x minus 5. So we now want P of 2. We want to see if x minus that is the remainder when dividing by this expression by x minus 2. So in this case now the coefficients of the polynomial are 2, minus 3, 4, and minus 5. And c is 2 because x minus 2 equals 0. So that means x is equal to 2. So in that case, x is equal to c. So our c is actually 2. So the sweet way to go is this coefficient 2 minus 3, 4 minus 5. Just line them up here and write your c right by this side. Now I'm just going to explain this, and then I'll go over to the worksheet and use this same method to look for the remainder of what I just did there. That's 104, 2,400 we got. We use synthetic method to get it. So now you have this coefficient. So what you're going to do is first, this 2 now drop it. This 2 comes down. So you now say 2 times 2, 4. So that the 4 comes under the next coefficient. Then you say minus 3 plus 4, 1. Okay. What do you do next? 2 times 1, 2. So this 2 comes under the next coefficient. 4 plus 2 is 6. Okay. Next, 2 times 6 is 12. Minus 5 plus 12, 7. So this 7 now is your remainder. So that's why when you divide, I think that was what we found before now. So if you put 2 into that expression, you see the remainder we got was 7, as you can see. All right. So we see that quotient coefficients. So the quotient coefficients are 2, 1, and 6. So this one now gives us the quotient. So the quotient coefficient is, hence Q of X is, so you start from the back, x raised power 0 plus, so this 6 times x raised power 0, then 1 times x raised power 1, 2 times x raised power 2. That's why you have 2x squared plus x plus 6. So the remainder is, the quotient is 2x squared, that's Q of X, is 2x squared plus x plus 7. And the remainder is 7, which is P of 2. Thus, P of X is x minus 2 into x squared plus x plus 6 plus 7, okay? Which is the remainder. So I'm going to go to the worksheet and use the same idea for, I'll use the same idea here. So what I want to do now is I want to divide, again, I have x raised power 4 minus 1 all over x minus 7. Again, using the synthetic method, so we have, so you can just create this kind of thing. Maybe this is too long. So let me just do it like this. So x raised power 4, don't forget, you have to fill up all the gaps. So that's x raised power 4 plus 0x cubed plus 0x squared, all right, plus 0x minus 1, very important, all over x minus 7, okay? So now, let me change the marker to green, okay? Or let me go blue even. So here, you put your C here. So you have, okay, of course, we have x minus 7 equals 0. That implies that x is equal to 7. So I put 7 here. Then I put the coefficient. So the first one is 1. The second one is 0. The third is 0. The fourth is 0. The fifth is 0. And then the last is minus 1. Or maybe I should have spaced all of that out. But it's okay. I think we can use this. So what I'm then going to do is I'm going to drop this 1. Okay? I drop this 1. So when I drop 1, so I have 7 times 1. That is 7. Okay? So I add 0 and 7. This is simply 7. So the next thing, I have 7 times 7, 49. Okay? 0 plus 49, that's 49. Next, I have 7 times 49. Okay, I guess that's too, that is too it's choking, so to speak. So let me allow for some space. Okay, so you have 1, 0, 0, 0, right? 1, 0, 0, 0, minus 1, okay? So C is 7 here. So drop this 1 now. So we have 1. 1 times 7 times 1 is 7. So 0 plus 7, we have 7. Then 7 times 7 now, 49, okay? 0 plus 49, that's 49. 7 times 49, that's 343. Then 0 plus 343, you have 343. In fact, I should have this cage because the last one, the last one will always give us the remainder. Then now 7 times 343, this is not minus, by the way, so pay attention to that. This is just 7. Okay, 7 times 343 is 2401. That's 49 times 49. So minus 1 plus 2401, that's 2,400. So now this is the remainder. Okay, this is simply the remainder. And then these are the coefficients of quotient. Okay, so we can say that so for x raised to power 4 minus 1 all over x minus 7, okay, the quotient Q of x is all those values. So that is starting from the back, 343 constant, 49x, 7x squared, then x cubed. So that's x cubed plus 7x squared plus 49x plus 343. So this is the quotient now. Then, and the remainder R is equal to 2,400. So that's exactly what we got when we substitute that directly. Okay, so that's the beautiful thing about this synthetic division. It's pretty fast. Okay, so okay, yeah, well, we can write like we've been doing, right? We can say, so I guess I want to change this. So x raised to power 4 minus 1 over x minus 7 is equal to what's that now? Okay, is it x cubed? I think it starts with x cubed. So x cubed plus 7x squared plus 49x plus 343, then plus the remainder, that's 2,400 all over x minus 7. So if you multiply through by x minus 7 now, this implies that x raised to power 4 minus 1 is equal to x minus 7 into x cubed plus 7x squared plus 49x plus 343 plus the remainder 2,400. Okay, so that means that, again, this is the dividend. That's what you're dividing. Then this is the divisor. This is the quotient. This is the quotient, and this is the remainder. This is the remainder. Okay, that's what we have right there. So why synthetic division is useful? I mean, you can already see that synthetic division is especially useful for fast evaluation of P of C using the remainder theorem, and it is good for checking roots. So if P of C is equal to 0, you know that expression the C is coming from, it actually can divide the polynomial. Then it is also good for factoring polynomial step by step. Once you find the root, you can get the quotient, right? It is much quicker and more compact than full polynomial long division for linear divisors x minus c. So if the divisor is not linear, then of course you have to do long division. You don't have a choice in that case. So this takes us to checking roots using the remainder theorem. So a root of 0 of polynomial p of x is a number c such that p of c is equal to 0. So if you put a value into a polynomial and you get 0, that means that x minus that value is automatically so if you put c into a polynomial, you get 0. So for the remainder theorem, the remainder when p of x is divided by x minus c is pc. Therefore, if p of c is 0, that means that the remainder is 0. And this leads to the factor theorem, which we're going to consider in the next video, by the way, but we still have a bit of thing to do before we leave. So this leads to the factor theorem. So factor theorem, x minus c is the factor of p of x, if and only if p of c is equal to 0. So this is the factor theorem, okay? So this linear divisor is a factor of the dividend if and only if the remainder P of C, we have established from the remainder theorem that the remainder is P of C. If the remainder is 0, that means nothing is remaining. That means x minus c divides P of x perfectly. Equivalently, we can say that P of x is x minus c times Q of x. That means the dividend is equal to the divisor multiplied by the quotient. No remainder. So since there's no remainder, so it means x minus c perfectly divides P of x. So this implies basically that P of c is equal to 0 in that case, okay? Because I mean, yeah, that means P of C is equal to 0. Because if you put C here, so P of C equals C minus C, so that's 0 times Q of X. So P of C is simply 0. So the procedure, how to check if C is a root, right? So check if C is a root of P of X, we can use either method 1. You can do direct substitution. So you compute P of C by substituting X equals C into P of X. So if P of C is 0, then C is a root of P of X. And that means if C is a root of P of X, that means X minus C is a factor of P of X. That means X minus C can divide P of X perfectly, right? Then if P of C is not equal to 0, then C is not a root. Then the remainder when dividing by X minus C will be P of C. So that takes us back to the remainder theorem that brought us here. Then we can do synthetic division like we did previously. So you can perform synthetic division of P of X by x minus c using the number c. So you can substitute directly following the remainder theorem, or you can do synthetic division, which is the next best thing after remainder theorem to check if there's a remainder or not. Then look at the final number, that is the remainder in the synthetic division table. If the remainder is 0, then c is the root, and x minus c is a factor. So if the remainder is not 0, then c is not a root. So like in the case of x raised to power 4, x raised to power 4 minus 1 over x minus 7. X minus 7, of course, is not a root of x raised to power 4 minus 1 because there's a remainder, a non-zero remainder, which is 2,400. Very important to note that. Okay. So imagine you want to check candidate roots for this. You have p of x equals x raised to power 3 minus 4x squared plus x plus 6. So you can test x, which is 1, 2, 3. So when c is equal to 1, for instance, if you use synthetic division, usually, so the coefficients are 1, minus 4, 1, and 6 for the polynomial. So you have 1, minus 4, 1, and 6. So if you check, if you try c equals 1, so if that means c is 1. So drop 1, 1 times 1, 1, minus 4 plus 1, that's minus 3. Next, 1 times minus 3, you have minus 3. 1 times minus 3, 1 minus 3, that's minus 2. 1 times minus 2, you have minus 2 here. 6 minus 2, that's 4. So this 4 now is a remainder. So it means that because 1 is giving us this remainder of 4. So remainder is 4, which is not 0. So that means x equals 1 is not a root. That means x, if you transfer 1 over there, that means x minus 1 is not a factor of this expression. That's step 1. So you can also try minus 1, right? For me, I would try minus 1. Okay, let me go and try minus 1 for this. Okay, well, what do I do now? Okay, should I just follow what I have here? Okay, so here I've tried 1. We can also try minus 1. So we have x cubed minus 4x squared plus x plus 6. So we want to see if x, so this simply means x minus 1 is not a factor. So what I want to try now is to check if x plus 1 is a factor of x raised to power 3 minus 4x squared, x raised to power 3 minus 4x squared plus x plus 6. Okay, so what do? So the coefficients, we can set that out easily. The coefficients of the polynomial are so for this, the coefficient is 1. For this, the coefficient is minus 4. For this, it's 1 again. For this, it's 6. And then if you're checking for 1, so you know that x plus 1 equals 0. That means x is equal to minus 1. So c, so that means x is equal to c, which is minus 1. So we can put minus 1 here. So here you drop 1. So minus 1 times 1, that's minus 1. That's this minus 1 times this 1 now. You get minus 1. So minus 4 minus 1, that's minus 5. Okay, of course, it's better you separate this because whatever you end up getting here will be your remainder. If it is 0, that means x plus 1 is a factor. So next thing we do, minus 1 times minus 5, that will give us 5, right? So 1 plus 5 is 6, okay? So next you go minus 1 times 6, that's minus 6. 6 minus 6 is 0. So that means that this, so it means, so with this, because we got 0 here now, so we see that the remainder is 0. So, so that simply means that x equals minus 1 is a factor. It is a factor of f of x equals x cubed minus 4x squared plus x plus 6. Okay, and x plus 1 is a factor. X plus 1 is a factor. So we transfer this one back now. So x plus 1 is a factor of f of x. So because we got 0 there, that means that x plus 1 is a factor. So that's the deal there. So but so when I'm doing long divisions like that, I try plus 1 minus 1. If I keep trying until I get something. So we have checked 1, it didn't work. So if you check 2 also, you see 2 also tells you it's a factor. So with that, it means x plus 1 is a factor, x minus 2 is also a factor. So in this case now you have this. So if you pick 2, if we are trying for c equals to that, we are assuming that x minus 2, whether it's a factor or not. So 2, you have 1, 2 times 1, 2 minus 4 times 2, minus 2. Then 2 times minus 2 minus 4, 1 times minus 4 minus 3. 2 times minus 3, that's minus 6. 6 minus 6, 0. So because you got 0 here, it means that x equals 2 is a factor. So x equals 2 is a root rather, and x minus 2 is a factor. Okay, the remainder is 0, so x equals 2 is a root, and x minus 2 is a factor. So the quotient has coefficients. So for the quotient has coefficients 1, minus 2, and minus 3. So p of x is x minus 2 into x squared minus 2, 2x minus 3. So we can now easily factorize this one. Okay, so factoring further, we can then factor further, right? So we can easily factorize. So in subsequent videos, we'll be learning how to factorize quadratic expression, which is, I mean, that's a popular thing, but I'm going to explain it. So factoring further and finding the root. So from p of x now, which is now x minus 2 equals x squared minus 2x minus 3. So we can factorize this to x. So for the quadratic, we have x squared minus 2x minus 3. So that can be x minus 3 into x plus 1. So p of x is x minus 2 into x minus 3 plus into x plus 1. Therefore, the roots will just be, equate all this to 0. So x minus 2 equals 0, that's x is 2. X minus 3 equals 0, x is 3. X plus 1 equals 0, x is minus 1. So that's the minus 1 I got over there. So you can verify that x is 3, x is minus 1 by checking p of 3 equals 0, p of minus 1 equals 0, or by doing synthetic division again with 3 and minus 1. So if you substitute 2, 3, and minus 1 into the original expression, you are going to get 0 for sure. So that means those are factors. So brief note on repeated roots. So sometimes you can have repeated roots, meaning that maybe you have 2 appear twice or 3 appears twice. So you have brief notes on repeated roots. So if x minus c raised power k is a factor of p of x for some integer k greater than 1, so that means x minus c appears more than once. So we can say c is a root of multiplicity k. So if it appears 3 times, it means that c is a root of multiplicity 3. Then repeating synthetic division by x minus c k times will give remainder 0 each time. So there's no point trying to disturb. So once you get it once, you are good. So after k division, the factor x minus c raised power k is fully removed from p of x. So at this level, it is usually enough to remember. So if p of c is 0, of course. So simple thing now, for the remainder theorem, if p of c is equal to 0, then x minus c is a factor of p of x. Simply, then if p of c is not equal to 0, then x minus c is not a factor of p of x. So, and if x minus c is a factor of p of x, that means that x equals c is a root of p of x. So it's a solution, it satisfies p of x. That's what that means. So with this, we come to the practice questions. The first one, let p of x be 3x cubed minus 2x squared plus x minus 4. Use the remainder theorem to find the remainder when p of x is divided by x minus 1. What do? Just put 1, okay? Because x minus 1 is 0, so x is equal to 1. So put 1. So your c now is 1. So you have 1 raised by 3, 3. That's 3 minus 2. All right, 3 minus 2 is 1 plus 1 again. That's 2. 2 minus 4. That's minus 2. So that means that x minus 1 does not. So there's a remainder that is not 0. So that means that x minus 1 does not divide this. So you can confirm using synthetic division. I mean, you know how to go about that. Let p of x be this. Find the remainder when p of x is divided by x plus 2 using direct substitution and synthetic division. We've done that before. Polynomial p of x leaves a remainder 7 when divided by x minus 2. What is p of 2? I mean, that means p of 2 is simply 7 because that's the remainder it leaves, for sure. So explain which theorem justifies the answer. That's the remainder theorem. Let p of x be this expression. Use synthetic division to test whether x equals 1 is a root of p of x. Based on your results, state whether x minus 1 is a factor. Of course, if x equals 1 is a root, then that means x minus 1 is a factor, basically. Then consider this. Use the remainder theorem. From your answer, determine which, if any, of x minus 2, x plus 1 are factors. You can try this out. Then question 6. Let p of x be this. Use synthetic division. If x1 is a root, factor p of x completely. So in the next video, we're going to do all this factoring completely as we get there. So for 7 now, polynomial p of x satisfies p of 1 is 0, p of 2 is 5, and p of minus 1 is minus 4. So what is the remainder when p of x is divided by x minus 2? So first of all, you need to, maybe you can make the polynomial out and then divide, and then you try the remainder theorem. So try your hands on all of this. Yeah, so with this, we'll come to the end of this interesting video about remainder theorem. Watch out for the factor theorem, which is connected to the remainder theorem in the next video. Let me know how helpful this is for you. If there's something you'd like to try out, feel very free to let me know, okay? If you have subscribed already, I thank you very much. But if you have not subscribed, of course, you want to go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Don't forget to try the practice questions, okay? After subscribing, of course, you want to take it a step further if possible. Become a member of the channel by clicking on join, and that comes to some special privileges like You can hang out with me if you're in the same, if you ever get to be in the same physical place at any point in time. Maybe we can, and then we can discuss anything I talk about on my channel, like mathematics, data analysis, data science, machine learning, scholarships, and so on and so forth, right? That's what you get as a member of the channel. One of the things you get at the very highest level for sure. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.